So let's go over bell work first to make sure we all know what these angles are called. So number one, Sneha, what did you say for number one? Okay. Mina, do you remember what number one was? Yeah. Oh, okay. Jack?
It's like complementary angles.
Congruent. They are the exact same measurement. Thank you. Congruent.
Oh, I thought it was the same.
Were yours jumbled up?
I thought it was the same thing, but they just flipped it upside down.
Yeah. Okay, so question number two, we're next to each other. Yes, Henry?
Adjacent.
Adjacent. 3 added up to 90 degrees. Mina, what was that? Yes, complementary. Yes. Okay, so number 4, Nora, what was that? Supplementary, because they add up to 180. Number 5, those are across a vertex from each other, Janaya. Vertical. Ava, what about number 6? Acute, because it's less than what? 90. And then 7, Pearson. Obtuse. Sutherland, what would number 8 be? Right. Captain, what was number 9? Vertex. Jacob, what's number 10?
Parallel.
And Jamaica, what's the last one? Perpendicular. Okay, so you have to understand those things moving forward. All right, so at this time, everybody should have their notes, something to write with. We'll do our notes for a little while, and then we'll do some practice at the end. Our essential question for today is, what relationships exist between angles within a transversal? So first we need to understand what a transversal is. So we're given this image, and it is 2 parallel lines and a line cutting across them. It says that AB is parallel to CD. Given these lines are in the same plane, they will never do what? Collide, intersect, touch, any of those words. I'm going to write intersect because they are parallel lines. Now line EF itself is what is technically the transversal. It means that it intersects at least 2 lines at a time. Can be way more than 2, but it has to be at least 2, because if it just intersects 1, it's not considered technically a transversal anymore. It's just an intersection of 2 lines. We're really only concerned when it intersects 2 or more. All right, so the next thing it tells us to do is to measure these. So I'm going to attempt to pull up my protractor on here. All right, so if I use this protractor, come on, man, move the right way. Okay. All right, so if I measure this first angle, and I get it correctly, that first angle is 120 degrees. Well, based upon what we know about lines, what's the measurement of a straight line? What's that? 180. So if this one's 120, what do you think this one should be? 60. Okay. So this same one up here is also 120, so this one is also 60. So it's looking like the majority of our angles, or in fact all of these angles, are either 120 or 60. So I know that 120 is an obtuse measurement, right? So all of these obtuse angles are 120. So this one's 120, this one's 120, this one's 120, and this one's 120. Okay, those specifically to each other, those are vertical. Okay, so then all the other ones that are acute must have been the other angle measurement, which was 60. So this is 60, 60, 60, and 60. Now this only works because these 2 lines are parallel. If they had been intersecting all kinds of crazy ways, I wouldn't know this. So you have a table that asks you to fill in the angle measurements. So what was EGA? Okay. EGB was? FGA was? FGB was? CHE? EHD? CHF,
60.
and then DHF, 120. Okay, so notice there are only two different angle measurements. There was 60 and 120. So when you have a transversal like this, any normal transversal, there's going to be one obtuse measurement and one acute measurement. The only time it wouldn't be that way is if we had perfectly perpendicular lines, and then what would all the angle measurements be there? 90. All of them would be 90 degrees. But in any other transversal where it's slanted like this, it could slant either way. If it's slanted, then one measurement's going to be obtuse, all the other ones are acute. So you see it's kind of like a little opposite zigzag here. All of these are equivalent to each other. And then the zigzag the other way, the blue ones, are all equivalent to each other. So what our goal is today is to learn, really mostly vocabulary-wise, what are these things called? What is the relationship called? Okay. So our very first one on our vocabulary here says vertical angles. So most of us probably knew that coming in the door. What are vertical angles? Nora, are you attempting to explain it? No? Negative? Anybody know?
Are we doing the whole package?
No, not the whole packet, only first half.
Angles are facing upwards.
Facing upwards?
Like they're open.
They don't have to open upwards. What do you mean, Jack?
Angles are like
Across a vertex. So angles across a vertex. We'll need to identify some examples from our image. So if I say angle EGB, based upon the angle I just picked, one person raise their hand and let me know which would be vertical from that. Anybody have an idea? Yes, sir? AGF, you said? AGH. Okay, so AGH, angle AGH, is vertical. So if I pick another set of examples, if I say angle FHD, which is in the bottom right corner, Captain, what is vertical to angle FHD? You said GHC? Yes, okay. Angle GHC. So for my my visual people, I'm going to go back one more time and show you. Let me clear this. So I said this one, and then this one was vertical. And then I said this one, and then he told me this one was vertical. So they are across from a vertex to each other. Well, yes, they have to share a vertex. That's what I'm saying. They're across the vertex from each other. Okay. All right, so our next vocab word is corresponding angles. So corresponding angles, basically, in simple words, they occupy the same position in the intersection. So we're going to write it as simple as we can. They occupy the same position in the intersection. So it's like they're hanging out on the same street corner, but a different intersection. So I'll show you what I mean. Occupy the same position in the intersection. So, an example for corresponding, if I was looking at angle EGB, that's where it is in this intersection. I'd have to look at the other intersection, the one that's in the same position, GHD. Those are corresponding. So let's give ourselves some examples. So corresponding, we've got angle EGB and GHD. EGB, GHD. EGB and GHD. So I'm going to give ourselves another example because there's like 4 different sets here. So if instead I focused on this angle right here, so AGH, angle AGH, Ava, what do you think is corresponding to angle AGH? CHF. Angle CHF. Those are corresponding. They're occupying the same position in the other intersection. Okay. Any questions about corresponding? All right. So let's move on to the next vocab word. So then we've got alternate interior. So alternate interior. Alternate means it has to be on opposite sides of the transversal. So they have to be on opposite sides of the transversal. The word interior means it has to be found inside the parallel lines. So opposite sides of the transversal, but inside the parallel lines. Okay, we're actually going to go back and do that, but they're actually equivalent. They're congruent to each other. So when I visually show you which ones they are, it'll make sense to you. Okay, so opposite sides of transversal, inside parallel lines. So some examples of that from our image here. If I've got this angle, it's inside the parallel lines. To be alternate interior, the other one would have to be this angle. These are alternate sides of the transversal, and they're in between the parallel lines. So some examples, we have BGH, so angle BGH, and angle GHC. So there's only one other set of alternate interior angles. So if I have this angle here, Henry, what angle is alternate interior to that one? Yes. So this would be the other alternate interior. So there was only two sets. They had to be in between the parallel lines. Yes.
How do you know what letter to start with?
As long as if you could have said AGE or EGA, and I would have taken it. Usually it's in alphabetical order, but it's technically it doesn't matter either way. Like as long as the vertex is in the middle and I can read which one you're talking about, we'll give you credit for it. Now in geometry they might get a little more strict about things, but as long as you've got the vertex in the middle, we'll know what you're talking about. Okay. All right, so the next one we have is alternate exterior. So it's almost the same as alternate interior, except it does have to be on the opposite sides of the transversal. But the difference is it needs to be outside of the parallel line. So opposite sides of transversal. But because it's alternate exterior, they have to be outside of the parallel lines. So there should only be two sets in our example that are alternate exterior. So opposite sides of transversal, outside of parallel lines. So if we look at our examples here, let me clear this. If one of them is AGE, Jacob, which one do you think is alternate exterior to that?
FHD.
Yes, alternate exterior would be FHD. So one set of alternate exterior, we can have AGE and FHD. So there's only one other set. Janaya, what would be the other set of alternate exterior? CHF? Okay. So what's the other one to that? EGB. That's a different color, but it doesn't look like it. Sorry. Okay, so all the ones that we just talked about, vertical, corresponding, alternate interior, and alternate exterior, those all have a specific type of relationship. Those are all congruent to each other. So you can write them individually or you can kind of circle them all, but these are congruent to each other. And what does that word mean again? Same measurement. So these are all congruent to each other. In fact, if you want to learn a symbol, I think the two lines with the line over it, I'm pretty sure that means congruent. It's been a while, but I'm going to write congruent. And congruent. So now we get to this last box. It's talking about supplementary angles. What does supplementary mean again?
Angle that
Add up to 180. So add to 180 degrees. So if they're not one of those relationships, then it must be a relationship where the two angles together add up to 180. So there's two main types that they focus on that do that. It is called consecutive. What does consecutive mean? Like one after another, right? Sometimes they use the wording same side. So they might call it consecutive, they might call it same side. There's an interior and there's an exterior. What do you think interior means? Inside of the parallel lines. Exterior must mean outside of the parallel lines. So this particular unit is very vocab heavy. A lot of it's just about you identifying what do we call these two angles in their relationship to each other. So let's get some examples of either one of those. So if I said for consecutive interior, if one of mine is EGB, the other one that's consecutive interior is this one right here, GHD. So angle, not EGB, that would be this one right here, I'm sorry. That's BGH. Angle BGH and GHD. Those are both on the inside, but they're both inside of the parallel lines. And they're on the same side of the transversal. So are those congruent to each other? No, those are the ones that are supplementary. They add up. So, yes?
So, are these interior and exterior consecutive? Yeah.
Well, for the ones we're filling out right now, yes.
Okay.
So the other one, the example of consecutive exterior would be like AGE, angle AGE. The one that is consecutive exterior to that one would be this one down here because they're outside of the parallel lines, but they're on the same side of the transversal. So angle AGE and angle CHF. Those are the consecutive exterior. So those are the only ones that have that relationship necessarily that add up to 180. So what do we call two angles that form a line together? Does anybody know? Well, what do they add up to? They add up to 180, right? But there's something else that you can call when two angles are next to each other and they form a line. It's called a linear pair. I just want you to know that. You're going to see it. So if I have two angles, well, I probably shouldn't have made it that way. If I have two angles and they make a line together, this is for people who didn't know, it's called a linear pair because it's a pair of angles that form a straight line. Just FYI. Yes, ma'am. Can you open that? All right, so the next thing we are to is there's this proof here where we're going to take what we've got and identify the other angle measurements, but we can't just say what the angle measurement is. We have to give a justification. Because there are so many different relationships, there's more than one justification that we could technically give. So based on the image, they give us 105. So next to angle number 1, it says given. Then they found angle number 2, which they said was 75 degrees because it's supplementary to angle number 1. Then they found angle number 3 and then said, well, it's 75 degrees because it's vertical to angle number 2. So when we find angle number 4's measurement, what is angle number 4's measurement? 105. So what is a justification that we could technically give? Okay, so, well, adjacent doesn't necessarily...
Vertical is angle number 1.
Okay, so vertical to 1 is one of them. Or we could have also said that it's supplementary or forms a linear pair with which angles? 2 and 3, right? because I could do 4 and 2 and that would make a perfect line, or I could do 4 and 3 and that would make a line. So you could have also said supplementary to angles 2 and 3. I'm just trying to show you there's more than one way you could have justified it. So we have angle 5 already, and it's corresponding to angle 1. It's in the same position on the intersection. So, Captain, what's angle number 6? Okay, could you give me a justification for it? Okay, I know we're just learning it. Anybody have any other words? Yes, Jack?
Supplementary to 8.
Supplementary to 8, but we don't technically have 8 written down yet, right? So based upon the ones that we know so far, could you give me something, Jack?
Opposite to 5.
Opposite to 5. Okay. Yes.
I don't know if this is right because I just looked in,
Mhm.
but the full line is 180, so we subtract.
Okay.
25.
Perfect. So what's that word called? Supplementary. Okay. So what she's saying is supplementary to which angle?
1.
Well, 6 is supplementary to 5. Okay. So I could have also said, based upon angle 6 and its relationship to angle 2, what would we call those? Corresponding. I could have said it's corresponding to angle 2. So there's multiple relationships here. Okay, so angle 7, Jacob, what do we think that is?
75.
What would be your reason there? What's its relationship to 6?
Oh, it's corresponding.
7 and 6? Vertical. Okay.
Vertical.
So vertical to 6. I know, that's why I've got a Quizlet, some flashcards in there for you. All right, and Swayze, angle 8. Okay, what would be your justification here? What's one of them we could say?
Vertical to 5.
That's correct. Vertical to angle 5. What else could we have said? Anyone else? Yes, Ava?
Corresponding to 4.
Okay, corresponding to 4. That's correct. Supplementary to 6, supplementary to 7. So knowing, yes, ma'am?
Does it have a relation with 1?
Okay, with question number 1, with angle 1. Yeah, so I know you just walked in, so that's a good observation. Class, anybody, what would we call 8 and 1 to each other?
Vertical. Outside.
Alternate exterior, yes. Okay. All right, so multiple ways to justify that. All right, so our last thing on our notes here, this one's the same situation except it's completely blank. So what's the first angle they give us? 4. So next to angle number 4, we're going to write 55 degrees, and that is given. I'm going to give you a minute, and I want you to fill in the others. If you want to do the measurements first, that's fine, but then go back and give an explanation based upon some kind of relationship. So we might have some different answers as long as it's based upon the relationship. Some of us put different. These are some example relationships, but there are at least like 2 or 3 different ways you could have justified it based upon what you knew. Okay. All right, so are there any questions necessarily about what we just did so far? I know you don't have it memorized, but about any of the answers up there. Okay. All right, at this time, you can hold on to those notes. We're going to finish.